Nuclear decay. Radioactivity is the process through which the nucleus of an unstable atom transforms into a stable one, along with releasing energy in the form of radiation. The nuclei of most atoms are very stable. However, there are some atoms that have unstable nuclei which throw out particles to make the nucleus more stable. This is a random process that depends only on the nature of the nucleus. One element discovered that emits these particles is radium, and the name radioactivity is given to this process. There are certain atoms that either have too many or too few neutrons or protons in their nuclei. This results in an imbalance between the forces holding them together, which leads to an excess of internal energy. Such atoms are said to be unstable or radioactive. So it's the excess internal energy that makes the nuclei of atoms radioactive. But what is the origin of this excess internal energy? We do not even need to invoke knowledge of nuclear forces to begin to understand this. You know that electrical charges of same signal repel each other. So, when there are protons in the nucleus, the repulsive forces are very strong. An interesting plot arises when the number of neutrons exploded versus the number of protons. Look at the diagram. The plot indicates that lighter nuclei are most stable, and this ratio is 1. This is the case with any nucleus that has up to 20 protons. As the atomic number increases beyond 20, a different trend becomes apparent. As the number of protons increases, more neutrons are needed to keep the nucleus stable. For example, lead has 82 protons and has 124 neutrons. The blue band indicates the region over which stable nuclei occur. Unstable nuclei occur outside this band. Protons and neutrons are called nucleons because they are in the nucleus. It's important for you to know the difference between radioactivity and radiation. Radiation is the energy or particles that are released during radioactive decay. The reactivity of a material refers to the rate at which it emits radiation. There are 4 types of radioactive emission. The alpha particle is formed from 2 protons and 2 neutrons. Beta particle is a fast-moving electron. Gamma ray is an electromagnetic wave. Neutron. Alpha decay. Nuclei with more than 82 protons usually emit an alpha particle when they decay, and it causes the nucleus to change into another nucleus with a mass number 4 less and an atomic number 2 less than the original one. Pay attention in these 2 examples. Beta decay. In a nucleus, there are only protons and neutrons, but a beta particle is made and ejected from a nucleus when a neutron turns into a proton and an electron. Nucleus above the band stability decays by beta emission. Take a look in this example. Gamma decay. After emitting an alpha particle or beta particle, some nuclei are left in an excited state and then give out a gamma ray. Gamma rays carry away from the nucleus a lot of energy, so that the nucleus is left in a more stable state. Gamma rays have no mass or charge, so when one is emitted, there is no change to the mass or atomic number of a nucleus. Neutron decay. Neutrons are emitted from some highly unstable nuclei. The effect of this is to reduce the mass number by 1, but the atomic number does not change. An example of neutron emission from helium-5 is given below. Ionization. All types of radiation cause ionization because they carry with enough energy to remove electrons from atoms in the material it passes through. This is why we must be careful when we handle radioactive materials. The radiation makes ions in our bodies, and these ions can then damage our body tissues. In a collision, alpha particles with their relatively large mass and charge have more of a chance of knocking an electron from an atom and cause ionization than the lighter beta particles. Gamma rays, which have no charge, are even less likely than beta particles to produce ionization. The different types of radiation are often compared in terms of their penetrating power, their ionizing power, and how far they can travel. Take a look in this diagram. Now it is your turn.